Hello everyone. The topic which we are going to take up today is nomenclature of the organic compounds. So as far as any competitive exam is concerned in chemistry, whether it is NEET, CET or JEE, there is a guaranteed question from the nomenclature of the organic compounds. We have to see why this nomenclature is very important. When you have a wide variety, there are millions of the organic compounds. So you have to put those organic compounds into certain blocks so that it is very easy to identify them. We'll solve the question answers one by one. So the first question which we have here is, the compound is given. In this compound, the C2C3 bond is of the type. So to find out C2C3 bond first, we have to number the organic compound. So this is the organic compound which is given. I'm going to rewrite it. Now, you can name it from this side. You can number it from this side. You can number even from this side. But when you number the organic compound, you should see the functional group. Here, the functional group is a triple bond. This is a functional group, and this should get a minimum number. If you are going to number from this side, this is 1, 2, 3, 4, 5, 6. And if you're going to number from this side, it would be 1, 2, 3, 4, 5, 6. And always the functional group should be given the minimum number. So here the triple bond is at first position and the double bond is at the fourth position. And if you consider here, the double bond is at the second position and the triple bond is at the fifth position. Always select the lowest set of locants. So this is the proper order. Now you see where exactly is your C2, C3. So this is C2, that C2 is carbon 2. And this is C3, that's carbon 3. This carbon, which is numbered as C2, this has a triple bond on one side. We should know that a singly bonded carbon is sp3 hybridized, and the doubly bonded carbon is sp2 hybridized, and a triply bonded carbon is sp hybridized. So if you see this order, the C2 is triply bonded, so this should be of sp type. So if you see the options A and C have sp, the other B and D are ruled out. And if you see the third carbon, this is involved only in the single bond, so this should be sp3. So the correct answer would be option C, that's sp and sp3. Let's move on to the second question now. Here, the group of heterocyclic compounds is. What exactly is a heterocyclic compound? When you classify the organic compounds into different varieties, there is a category which is called as heterocyclic. The meaning of hetero is different. Cycle is a ring. So if there is any atom in the ring apart from the carbon, then it is called as heterocyclic. Any atom other from carbon, say it can be sulfur, it can be oxygen, it can be nitrogen, etc. We'll see the structures. The phenol, the structure of phenol is like this. And the furan, this is the structure of furan. And then in the option B, you have furan and the thiophene. Furan is the same one. And the thiophene is this one. And the option C is thiophene and the phenol. We have already written the structures, so I must name it. So this is phenol, this is furan, this is thiophene, and the last one is the aniline. Aniline is this one. According to the definition, the compound which has hetero atom in the ring, you can see these have oxygen and the nitrogen outside the ring, whereas these have furan and the thiophene have the hetero atom inside the ring. So furan and thiophene would be the answer. So this is a set of compounds which have the hetero atom inside the ring, which are called as heterocyclic compounds. We'll move on to the third question. Which of the following is the first member of ester homologous series? So what exactly is an ester? Ester is represented as RCOOR, where R are the alkyl groups. And homologous series is the one which has a single general formula, which can be represented using a single general formula. So I can replace this R by the alkyl group. First, what I can do is replace this by H, replace this by H. If I replace this by H, this becomes carboxylic acid. This is not an ester. So what I can do is replace this by the next member, that's CH3, and retain H in this place. So I'm going to get the compound H C double bond O O CH3. This is the first ester, the first member of the ester family. So someone is saying hi. So here, if you take this side, there is one carbon. There is one carbon this side also. So whenever you have one carbon, the root word will be meth on both the sides. Just don't worry about any other options. Just check where there are two meth groups. So it should be methyl methanoate, option C. And esters are named with OATE. So the correct answer would be option C. This is methyl. This is the side chain. This is the main chain, which consists of one carbon atom. So it is methanoate. So let's move on to the fourth question. What is not true about the homologous series? Homologous series, it is a series of organic compounds which are represented by a single general formula. So you can consider any homologous series as example. For example, if you take the alkane, these have the same functional group. That's a single bond. And the general formula is CN H2N plus 2, where N is the number of carbon atoms to N plus 2. So what's not true? Not true. You have to read the question properly, because sometimes what happens when you see this, you read it as what is true about the homologous series, then you may go wrong. So all the members have the similar chemical properties. This is true because the compounds which have the same functional group, they behave similarly. So alkanes or any homologous series, they contain the same functional group. So this is true about the homologous series. And their physical properties vary slightly. See, when you go from one member to the other, for example, you can substitute one here, C1H4. The second member would be C2H6. The third member would be C3H8 in the alkane homologous series. When you move from one member to the next member, you can see the mass is going to increase. There is only one carbon and 4 hydrogen in the first compound, whereas in the second compound, there will be more number of atoms, because of which the molecular mass and the density, all this boiling property, boiling points, all these are going to vary. So the physical properties can vary slightly. And the third option is they can be represented by a single general formula. Yes, we got all these members using the single general formula. So this is also correct. The second one is also correct. All these are true about the homologous series. Adjacent members differ in the molecular mass by 16. This is the last option which is left. So what is the difference between the first and the second? That's a consecutive members. If you see that, that would be CH2, which is called as methylene group. If you consider the mass, carbon is 12, hydrogen is 1 times 2, because there are 2 hydrogens. So the difference would be 14. So the successive members are going to differ in their molecular mass by 16. Not 16, it should be 14. So the one which is not true, correct answer is the option D. Let's go to the next question. The compound seems a bit complicated. We are going to write the structure first. The IUPAC name of the following is. We'll write the structure. See how many carbons are in the main chain. This is the carbon which is present in the main chain. This is the carbon which is present in the main chain. And this is the carbon which is present in the main chain. So let's write 3 first. 1 in the second one and the third one. We'll start from this end. For this carbon, there are 2 groups that CH2-CH3 are attached. So one is CH2-CH3 here. The other would be CH2-CH3 here. So we are done with the first one. We'll go to the next one. That's C, which is attached to just CH3. I'm writing it here. And the next carbon, this is attached to CH2CH3. So I'm writing it here like CH2CH3, and it is also attached to two groups, that's CH, that's the middle carbon, and two CH3 are attached to it. Now I have to number and select the longest chain possible. Before that, I have to complete the number of bonds in between. So always the valency of the carbon is 4. So this carbon just needs a single bond, whereas this carbon has 2 bonds. So you need to fill double bond here. Okay. So after this, you're going to select the main chain. When you select the main chain, you have to consider the functional group. This is a functional group which should get a minimum number. And then you have to select the longest chain. I'm going to select my longest chain like this. This is my longest chain possible. Yeah, here it is. So this should get the minimum number. So I'm going to name it from this end. 1, 2, 3, 4, 5, 6, 7. If I name it like this, the first thing what you can do is see the position of the double bond. That's 3. Select where there is a double bond at the third position. Option A and option C. Now select how many number of carbon atoms are there in the main chain. There are 7. So the root word is hept. So hept 3-ene would be the correct answer. So you have at A and C. Now you see the number of substituent. One ethyl group is at the third position. And there is one more ethyl which is at the 5th position. So this is one ethyl group. This is one ethyl group at 3 and 5 position. So it should be 3,5 diethyl. So among option A and C, you have 3,5 diethyl in both the cases. And then at the 4th carbon, you have methyl. And at the 6th carbon, also you have methyl. So it's 3,5 diethyl, 5. At the 5th position, there is isopropyl and 4,6 dimethyl heptene. So this would be the right answer. The IUPAC name of the compound, that's glycerol. This is the substance which is used to cry in the movies that's applied. So that is glycerin, I think, but glycerol. Let's write the structure of the compound. There are 3 carbon atoms in the chain C, C, C. So if I'm going to write it C, 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 then for every carbon, there is OH attached. And now there is a CH2 here, there is a CH here, there is CH2 here. So this is a compound. Just see, whenever you write this type of structure, you have to see the valency of the carbon is balanced and it should be 4. Otherwise, you have to put a double bond somewhere in between where the valence is not satisfied. So here, now you have to number the carbon atoms which are in the main chain. So it should be 1, 2, and the 3. Now, all these OH are the functional groups. So how are you going to name them if they are the functional group? What you are going to do? There are 3 OH groups that should be, there should be 1, 2, 3. You see where there is 1, 2, 3. Option A, option C, option D has 1, 2, 3. And after that, the functional group is named as a suffix which comes at the end. And OH is alcohol. For that, you are going to give the suffix as OL. So alcohol is OL. Now you see the example, the options. That's triol. There are 3 OH groups. That's triol. So the main chain is propane. At 1, 2, 3 position, there are alcohol groups. So the correct answer would be option D. Let's move to the next question. Number of tertiary carbon and the primary hydrogen respectively. So the tertiary carbon refers to a carbon which is bonded to 3 other carbons. Okay, 3 other groups. And the primary hydrogen refers to the hydrogen which is attached to the primary carbon. That's just like the CH3 group. This carbon is primary carbon and these hydrogens are primary hydrogens. So here in the structure, Me refers to CH3. So let me write the structure once again. HC CH3, that's Me, methyl CH3. And then the next carbon with CH3, and H here, the next carbon with CH3 groups, 2 CH3 groups, you can write it down, and then H, and then you have CH3 and the CH3. So which is easier for you? You find out the number of hydrogens which is attached to just the carbon. Okay. So which is the primary carbon? A carbon which is attached to only one other carbon. That would be, this is primary carbon, this is primary carbon, this is primary carbon, this is also a primary carbon, this is a primary carbon, this is a primary carbon, and also this is a primary carbon. Now you count the number of hydrogens present in them. So 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3. So it should be 3. I'm counting the number of hydrogens. So that will be 21. Now just select the option which has 21 number of hydrogens. So option A would be the right answer. But you can see the tertiary carbon is a carbon which is attached to 3 carbon atoms. So this is one tertiary. This is again one tertiary. This is again one tertiary. So there are 3, which is already written. Let's move on to the next question. The correct IUPAC name is, so the organic compounds are given and their proper names are also given. Hi everyone. So the correct IUPAC name is what you have to select. And now the first, let's go to the first. 2-methyl-3-butanone. The main chain is this one. You are going to number it as 1, 2, 3, 4 because the double bonded carbon should get the priority. So butanone, the butanone is at the second position. It should be the other way. 3-methyl-2-butanone. So this is not the correct one. This name for the particular compound given is not right. And the second option which we have is 2,3-dimethyl-pentane. So this is our main chain. You have to include the main chain, the double bond. So it should be our main chain. 1, 2, 3, 4, and 5. So the pentane, immediately you can see there is a double bond. So it should be pentene instead of pentane. Don't check the other answers like a 2,3-dimethyl. You don't check it because the root word and the suffix itself is wrong. The third one, 4-methyl-2-pentyne. So CH3, C, triple bond C, then CH. For this 2 CH3 groups are attached. Now, if you consider this, how are you going to number it? You start from this end because a triple bond should get a lower number, 1, 2, 3, 4, 5. So at the 4th position, you have methyl group. And at the 2nd position, you have a triple bond. And there are 5 carbon atoms in the main chain. So the correct one, the correct IUPAC naming would be the option C. And see, just the option D, there is a double bond between CH and the Cl, which is not at all possible. Okay, so the correct IUPAC name would be option C. I'm going to the next question right now. The correct IUPAC name of the compound. The compound is given. You have to select the longest chain. Once you select the longest chain, what you are going to do? You have to give the lowest number to the double bond which is given. If you're getting confused with this type of structure, just write it again. Just write C, this one, and then the next C, then this C. Just write as it is, double bond at C. We can fill up the hydrogens later. C and C. And for this carbon, you have C and C. Now fill with hydrogen, CH3, CH2. How do you fill with hydrogens? You know the valency of the number of bonds possible for carbon are 4. So you are based on that, you are going to fill them. CH2, and there is CH, and it is CH2 here, CH3 here, and this one is CH2, this is CH3. Now what you're going to do next is, you're going to number it. When you number, you have to select the longest chain. If you go by this way, 1, 2, 3, 4, 5, 6, there are 6 carbon atoms, but this particular group is a very big one, bulkier one. So you can't go for that according to the rules. So 1, 2, 3, 4, 5, 6 is what you can do. Now, see, in the given options, there are 6 carbon atoms, so it should be hex. And after that, there is a double bond at the first position. So retain hex 1 in everywhere and rule out the other options. So option A and B are gone now. Now see the position of the substituents. At the third position, you have a group which is called as propyl, because there are 3 carbon atoms. So this should be propyl at the third position. And at the fourth position, you have ethyl group. There are 2 carbon atoms, so this should be ethyl group. But when you write the name, E comes first in the alphabetical order before P. So it's 4 ethyl and 3 propyl, hex 1 in. So option D would be the right answer. Number of secondary carbon atoms present in the above compounds are respectively. Let's write the structure first, then decide. This is a benzene. The first one is benzene. We are going to replace the corners by the carbon atoms now. And there are alternate single and the double bonds here. And you're going to write CH everywhere, because to satisfy the valency. Now you see the secondary carbon in the sense a carbon is attached to 2 other carbons. So this carbon is attached to 2 carbons. This carbon is attached to 2 other carbons on both the sides. This carbon is also attached to 2 other carbons. Even this carbon is attached. So all the carbons which are present here are attached to 2 other carbons. So there are 6 secondary carbon atoms. So retain whatever has the first option as 6. So option A and D remain. And go to the second compound now. In the second compound, one of the hydrogens in the same structure is replaced by this hydrogen is replaced by CH3. Rest, everything is the same. Now what happens? This becomes a tertiary carbon. Rest are unchanged. So again, they have just the secondary carbon. So there will be 5 secondary carbons. So the correct answer would be option A. The next question which we have here is the IUPAC name of acetyl acetone. So what exactly is acetyl acetone? This is a common name. We have to write the structure first and then decide. This is the actual structure of acetyl acetone. Now when the actual structure is given, so you should know there are some of the compounds whose structure you should know if their general name is given. So if it is acetyl acetone, how do you name this? How are you going to select the chain? Since the double bonded O, that's a ketone group. So first you see the functional group, that's a ketone. And there are 2 ketones, 2 ketone groups. So dione should be there because it is repeating. Now you just have to number it. 1, 2, 3, 4, 5. If you number from this end also, you're going to get the locants at the same position or the functional group at the same position. So both way of numbering is correct. At the 2 and 4 position, you have dione. So you have option B, C, and D. So it is 2, 4 dione. After that, count the number of carbon atoms in the main chain. It would be 5. So it's pentane 2, 4 dione, which is the right answer. We have the next question here. In but 1-ene-3-wine, number of sigma and the pi bonds are respectively. First, you have to write the proper structure of the molecule. Then only you will be able to identify the sigma and the pi bonds. The sigma bond is a single bond. This you should remember. And a double bond has 1 sigma and 1 pi bond. And if it is a triple bond, then there will be 1 sigma and 2 pi bonds. Now let's write the structure of the compound whose name is given. But this question has appeared in 2 papers. So this type of question. So but 1-ene-3-wine. But in the sense there are 4 carbon atoms, 1, 2, 3, and 4. At the first position, I'm just starting from a left side. That's the way we write, right? So there is a double bond here. And at the third position, so this is 1, this is 2, and this is 3, and this is 4. So at the third position, wine in the sense there will be a triple bond. Now let's write the number of hydrogen. Let's balance the valency. Let's complete the valency. So hydrogen. This carbon has all the four bonds satisfied. So here there is one hydrogen. So let's calculate the pi bonds first, because pi bond is easier to calculate. So here there is a pi bond, and here there is a pi bond, and here there is a pi bond. So there are 3 pi bonds basically. When there are 3 pi bonds, you can rule out the other answers. That's 3 is there. So option B and D are remaining. Now calculate the sigma bonds. Single bonds are sigma 1, 2, 3, 4, and the middle one 5 and 6. That's right. We are remaining with the one here. So 1, 2, 3, 4, 5, 6, 7. So it should be 7 and 3. So you should, again, you have to see first sigma is given and then pi bond is given. So they may give it as 3 and 7 also. So that way you should be careful. So the correct answer would be option B, 7 and 3. Our next question is here. What's the correct order of carbon to carbon bond length? So the compounds given, if you see them, all of them contain the 2 carbon atoms. So the first one here, C2H6. Let me write the structures first. C2H6, that's CH3CH3. This is C2H6, which is called as ethene. And the second one, C2H4 is given. That's C double bond C. That's CH2CH. This is very basic. I think you all know this. This is ethene. There is a double bond, so that's why the name ethene. And there is a triple bond in the next compound, CH2CH, C2H2, that's ethane. Now this is C2H4, this is C2H2. Now your role is to find out, the question is to find out which is the correct order of CC bond length. So there is a single bond here, carbon-carbon single bond. So there is just, consider the 2 people are holding just 1 rope, and in the next one 2 people are holding 2 ropes, which is which makes the bond stronger. And the next one, there are 2 carbon atoms which are sharing 3 pairs of electrons. There are 3 covalent bonds. So when you move from 1 bond to 2 bonds to 3 bonds, the bond becomes stronger and the bond length is going to decrease. So the thing which you have to apply here is, more is the bond, stronger will be the bond. When the bond becomes stronger, when people are very close to each other, their bond is very strong, right? So the stronger the bond, shorter will be the bond length. If you see the bond lengths, this comes out to be 154 picometer, and this comes out to be 133 picometer, and this is something around 125 picometer. So if you don't know this in exam, it's fine, but you should know what makes the bond shorter. So the one with the shortest bond length would be C2H2. Just see where C2H2 has the shortest bond length and C2H6 has a highest bond length. So the correct order, C2H6 has highest bond length, and then comes C2H4, and then comes C2H2. This has the shortest bond length. So the correct answer would be option A. What are the changes in the hybridization of carbon in addition halogenation reaction of ethene? So what you have to do is, you have to take the ethene. That's CH2 double bond CH2. There exists a double bond. Whenever there is a double bond, you should know that the carbon which is involved in this double bond is sp2 hybridized. So this is the starting material. So whenever you have sp2, just see the options which have sp2. That's sp2 to sp3 and sp2 to sp2, B and C. Just make use of common sense. What are the changes? There should be some changes when the addition reaction, addition means something is getting added. So the option C is less likely to be the correct answer. But still, let's see. You're going to add chlorine, halogenation in the sense you are going to add some halogen, say X2. One X is going to add here, the other X is going to add here. So the compound which is going to become is CH2 with one X here and CH2 with the other X here. So the double bond has been converted to a single bond. Whenever there is a single bond, we know that the hybridization of carbon is sp3. So the correct answer would be starting from sp2 to sp3. So the right answer would be option B. the IUPAC name of the compound which is given here. To know the IUPAC name, you should number it properly. So this is not benzene ring. You should remember it. And now, always the double bond gets a priority. So let's start from here where the double bond starts, and also there is a substituent group. So I'm starting from here 1. I can't go by this way, but that doesn't include the double bond. So I should go by this way: 1, 2, 3, 4, 5, 6. So there are 6 carbon atoms basically, and chlorine is at the first position. Just see where there is chlorine at the first position. So the option C, that should be the answer, because we don't have any chlorine in any other position. So at the first position there is chlorine, at the third position there is bromine, but C comes afterwards in the alphabetical order. B comes first. That's why the name 3-bromo in the beginning. Then 1-chloro. You should remember to add cyclo because it is a cyclic compound, and then hexene. There is 1 double bond at the first position, so you need not mention it as hex 1 in. The next question: the number and the type of bonds between 2 carbon atoms in the calcium carbide. So let's write the structure of calcium carbide first, then we'll calculate the number and the type of bonds. So this question has appeared, this type of question has appeared already. So you should know how to calculate this. Calcium carbide, the formula of calcium carbide is CaC2. That means Ca, the calcium, we know that it is divalent, and the C2, that's minus, 2 minus. One carbon has 1 minus, the other carbon also has 1 minus charge. So what can be the, since they carry -1 charge, there should be a triple bond between them. And this is in the ionic form. So you don't consider the bond between Ca and C2. You just consider the bond between 2 carbon atoms here. And we all clearly know that whenever there is a triple bond, one of them should be a sigma and 2 of them should be pi. So 1 sigma and 2 pi bonds, the correct answer would be option B. Which of the following is a heterocyclic compound is our next question. How do we find it out? What are you going to do? It's pretty simple. Just see whether it is a cyclic compound first. Whenever the substance is heterocyclic, that means it should be a cycle first. So all these are in the ring form, cycle in the sense not the regular cycle, it's a ring. So if you consider this, already the option B has no ring, it is an open chain structure, so that option is ruled out. And then you have option A, C, and D. And here there should be a heteroatom. The meaning of heterocyclic is there should be a heteroatom, which is a different atom than carbon. That can be sulfur, that can be oxygen, that can be nitrogen. So in the ring, this carbon and this here, the oxygen is outside the ring. So this is not a heterocyclic compound. And here the sulfur is inside the ring. So this should be a heterocyclic compound. So the correct answer would be option A, and this is called as thiophene. Let's go to the next problem, next question. What first? Yeah, that's right answer. First, correct. But I can't read your name. It's a bit complicated. Mention the IUPAC name of CH3, CH2, COO, CH3. This is an ester of the form RCOOR. So this becomes the main chain and this becomes the substituent. So let's write it. CH3, CH2. I'm waiting for the answer this time, guys. So it's CH3, CH2, C double bond OO, CH3. So this is the main chain. And you start the numbering from this, from the end, which is C double bond OO. So 1, 2, 3. There should be 3 carbon atoms. So this should be propane, prop, and the type of bonding is ane, and it is an ester. So this should be propanoate. So see the answers which have propanoate. So option C and D have propanoate. So select one among them. Oh, both of them are right. So it should be methyl propanoate. I'm going to just select option C, because let it be option D as ethyl propanoate, because it is a typo. Sorry for that. And the correct answer would be option C, that's methyl propanoate. Mention the IUPAC name of the next compound, which we have here as. I'm going to rewrite the compound now. I'm just checking if anyone has the answer. N, C, and CH2, CH, CH2, Cn, and CH2Cn. You can go by any ways, right from here to down to top, or from this way to this way. Somewhere you have to leave CH2Cn. That's for sure. So let's consider this as my main chain. Once I select my main chain, how many number of carbon atoms are there? 1, 2, 3, 4, 5. Let me write it as I can number from this side, also from the from left to right, also from right to left, but it doesn't matter because from wherever you number the substituent, that's at the third position. So just see there are 5 carbon atoms, so it should be pentane. Rule out all the other options. So only option B is left. That should be the right answer. Dinitrile, because we are going to use a nitrile here, because Cn, when it is named as a suffix, if it comes in the prefix, you can see that 3-cyanomethyl. At the third position, one of the hydrogens of the methyl group is replaced by the cyanide. So this should be 3-cyanomethyl pentane. There are 5 carbon atoms, so pentane. At the first and the fifth position, there are 2 Cn groups, so that should be nitrile. So the option B would be the right answer. There is a swastik here. We have to find out the IUPAC name. I'm going to write it properly. So the first one is carbon, all the corners. And you should remember this point also has a carbon. Sometimes what happens is we forget to mention it. And this is a carbon, this is a carbon, this is a carbon, this is a carbon. And we are going to fill the hydrogens. For time being, I'm not going to write the hydrogens because I think you all know how many hydrogens you have to put everywhere. Now let me select the main chain, the longest chain. I can select from this way or this way, whatever way I want. This will be my main chain. You can select the other way too. It's up to you because the substituents are at the third position from wherever you select. So that way this compound makes things easier. Right. So at the third position, there are 5 carbon atoms in the main chain. So that should be a pentane, since there is no double bond anywhere. So when it is pentane, you can select option A, C, and D. Option B is ruled out. And see, there are 2 carbon atoms at the third position, and there are 2 carbon atoms at the third position. So these groups are identical. So they are ethyl groups. So 3,3, because both are at the attached to carbon number 3, 3,3 diethyl pentane would be the right answer. That's option D. Let's move on to the next question. Homologous series of alkanols have the general formula. So we already discussed about the homologous series. So homologous series is this is a series of compounds which are represented by a single general formula. That's what you have to remember. And you should know what exactly is alkanol. It is a combination of alkane plus ol. Ol refers to the alcohols. The general formula of alkane is CnH2n plus 2. And remove one hydrogen here. That becomes CnH2n plus 1 and replace that by OH. One of the hydrogens in the alkane is replaced by alcohol, that's OH, is going to give you the alkanol. Now again you count the number of carbons, CnH, 2n plus 1 is there, and again one hydrogen is there. So that should be 2n plus 2. And there is one oxygen. So the correct general formula for alkanols is CnH2n plus 2 plus O and OO. That's option D. That's the right answer. And you can rule out the option A and B because the general formula for alkane itself is CnH2n plus 2. So these do not have that. And double O2 doesn't come in alcohols unless it is a diol. It's not an alkanol. Okay, so there is a probability that you get confused with the option C and D because you are going to replace just one hydrogen by one oxygen. That's not the case. You have to replace one hydrogen by one OH group. Oh, the option is wrong, but I appreciate you for attempting the question. That's good to know. The 22nd one. So here it is assertion. What you have to do is an assertion is given, and that's a sentence statement, and the reason for that assertion is also mentioned. Now you have to see whether the assertion is right, whether or it is wrong, or whether a reason is right or it is wrong, and whether A and R go well with each other, or A is right, R is right, which is not the, but R is not the correct explanation for A. All these possibilities you have to see. So the given compound, just see first whether A and R are right. Then we can go for whether R is the right reason for assertion A. So the first one is a compound is given, that is this one. So this is a cyclo. So this should be cyclo, and 6 members in the ring. So this should be cyclohexane, and Cn is carbonitrile because it is outside the ring. Cn is outside the ring, so we are not mentioning it. So that's why carbonitrile. This is called as cyclohexane carbonitrile. So our assertion is right. So we are left with option A, B, C. Option D is ruled out because here our assertion is incorrect. Let's see whether R is correct. Suffix nitrile is given to the Cn group, which is outside the ring. Yeah, you can name the suffix as carbonitrile, or you can even name it as nitrile when it comes to the regular compounds where you are going to include that Cn in the ring, then Cn in the chain, then it becomes nitrile. If you're going to keep it outside the ring, then it should be carbonitrile. So even the suffix is right, and you have to see. So A is right, R is right. So you have the option A and B. And the reason is the correct explanation for assertion A. So A should be the right answer. Okay, so we are given with some compounds. These are not the IUPAC names. That's what I told in the beginning. You should remember some of the compounds, at least their formula or what these group correspond to. Then only you will be able to identify the compounds. So the general names are given, and you have to write you have to match which options are correct. So it's quite easy if you remember. So the aldehyde, let's go with the simplest one. If you feel anhydride, acetate, amide, aldehyde, everything is a little difficult, you go with the simplest option, that is acetaldehyde. Aldehyde is CHO. That's what is aldehyde. So whenever a question is given like this, just go for the simplest option, then rule out the other option, so that instead of getting 100 as a wrong answer, you're going to remove 2 options, so that you're going to get 50 chances are there to get the question corrected. So acetaldehyde, so that's option S will go with option W. Just see where they are. So you are ruling out the option, these 2 options. Now what else you know? Amide, that's quite pretty easy. Amide is CONH2. You need not see the first numbers because formic, methyl, all of the given options, they have different functional groups. So you need not worry about formic, methyl, acid, everything. Just see the functional group and take it. It will be the right answer. So this will be amide. So amide option R, that will go with option Z. What's that? So you have option R and a Z. So S with the W, option R and the Z. So this would be the right answer. Let's check the other answers as well. P is anhydride. Anhydride is Y. Anhydride is when you are going to take 2 acid molecules. That's the carboxylic acid molecules, and you're going to heat it in the presence of some acid. So the dehydration takes place. And anhydride, an is removal of water. Anhydride. So from 2 carboxylic acid, water molecule is removed. Methyl acetate. This is the ester. So the correct answer is option C. So we have no other answers so far. I'm going to the next one. That's question number 24. Match the column X with the column Y and mention the correct option. Again, you see which is easier. then go for the rest. That's the rule which you are going to follow. So I'll go with the option D because that seems easier for me. CH2 double bond CH. I'm going with the option D to be precise. Now, there is some group here that is directly attached to the double bond, and it is called as allylic group. So option D will go with the allyl. Do you have that anywhere? Sorry, this should be vinyl. I'm extremely sorry. This is vinyl. Allyl is this one. A carbon is attached to a carbon which is attached to a double bond. So this should be a vinyl. So option D is going with R. See where D is bonded with R. So C and D. Now let's go to the other options as well. Which is easier for me? The next one, option C. I'm going with option C. C, that is attached to 3 carbon atoms, 3 CH3 groups. So the carbon which is attached to 3 other carbons is called as tertiary carbon. And there are 4 carbon atoms together. So this should be tertiary butyl. And this one is option C, that is going with tertiary butyl, that's P. Then C with P. So you have got your answer, that's D. Where A is going with the T. A is nothing but isopropyl. There are 3 carbon atoms. So this is a propyl, and second position you have something attached. So this should be tertiary. This should be isopropyl, and the B, option B here. Here it should be the secondary butyl because it's a butyl group, butane group, and something is attached to the second position. So this should be secondary butyl. The next question which we have here is the structure of the compound whose IUPAC name is 3-ethyl 2-hydroxy 4-methyl hex, that 3-ene 5-inoic acid. Seems too long, but it's quite easy. See, oic acid, that's COH. That should be given the priority. You start the numbering from COH. So everywhere COH, you start the numbering from COH group. And you don't have any option. You have to go this way, from here to this way in all the compounds. Immediately identify the OH group. That's hydroxy. That's at the second position. So here is the second position. So no need to worry. Just put it as the right answer, the option B. But still we can go ahead. If there is something with OH here, let's proceed for the 3-ethyl. What is that? At the third position, there is a ethyl group. Here it is not ethyl group. And after that, 4 comes here, 5 comes here, 6 comes here. At the third position, you have a double bond. That's 3-ene. And at the fourth position, you have a methyl group. That's right. And at the fifth position, you have wine, triple bond. So option B would be the right answer. So whenever this type of a big name is given, don't get panic. Just see what you can do from the given long name. Just identify some of the functional group, give the priority, and identify the side chains so that you'll be definitely able to crack it. The IUPAC name of the compound. So the compound is given and you are asked to find out the IUPAC name. What you're going to do here? If this type of bond line structure, this is called as bond line formula, if that is going to confuse you, write the proper structure. You have enough of time, right, to do inky pinky. So this is CH3, here it is C, and here it is CH3. Let's satisfy the valency of carbon later. C double bond O, and here is Cl. Now satisfy the valency, the CH and CH. Now, how are you going to name it? Select the longest chain first. And that should include the functional group, the COCl. And here, I'm starting with this one. That should be given the number 1. Ma'am, where is methyl hex? Let me come back to that. Where is methyl hex? See, I have come back to this. You have asked where is methyl hex. So for methyl hex, you can see that at the 4th position, there is a methyl group. You can see that, right? So at the 4th position, you have methyl. And hex is the total number of carbon atoms in the main chain, which I have included, which I have marked. Hope that's clear. And now there are 5 carbon atoms in the main chain. 1, 2, 3, 4, 5. So retain what is pent. So option A, B, and D remain, whereas option C is ruled out. And since you have numbered from here, the 3 and the 2 contain the methyl groups. So it should be 2, 3 dimethyl pentanoyl, because that contains C double bond O as well as Cl. So that should be pentanoyl chloride. Option D would be the right answer. Now let me go to this one. The total number of pi bond electrons in the following structure. We already know the pi bond refers to a double bond. Whenever you say pi bond, if it is like this, you are not considering it as 2 pi bonds. One of them is pi, the other one is sigma. That you have to remember. Just check where are the double bonds. Here there is one double bond. Here there is one double bond, out of which one would be sigma, the other would be pi. So here there is a double bond, here there is a double bond. So how many double bonds are there? There are 4 bonds. Immediately what you are going to do? Tick 4. That's option A. No. Check the question properly. Again, read the question properly. Pi bond electrons is the question. Then the answer will change definitely. And what is pi bond electron? We know that each covalent bond, generally, when we say one covalent bond is formed by the sharing of 2 electrons. That means if there are 4 pi bonds, double the number, there should be 8 electrons. So the correct answer would be option B, not option A. The structure of isobutyl. Yeah, that's right answer. Option B, good one. So we have the question number 28. That's the structure of isobutyl group in the organic compound. What exactly is isobutyl? There should be 4 carbon atoms together. That you have to remember. I'm changing the color of ink to make it more colorful. Yeah, here we go. So when you say isobutyl, basically there should be total number of carbon atoms should be 4. This is 4. This is 4. Option B is also 4. Option A is also 4. Whenever you say isobutyl, it refers to isobutane. What exactly is isobutane? Isobutane is the one. Do you have any answers for this? Option B. Okay. Option B. Let's see whether it is a correct option or no. So you are continuously answering. Happy for that. Isobutane in the sense, iso refers to the second position. So there are basically 4 carbon atoms. And at the second position, there is one more carbon attached. This is what isobutane is. Now, this is the same way. You can see 1, 2, 3, and one group is attached to the second position. Or you can name from this way also if you want. 1, 2, 3. So some group is attached at the second position, that's CH3. So the correct answer would be option A. I'm sorry, the answer is option A. Don't worry, you can get it right in the next time. So we have the next question. The correct structure of 2,6 dimethyl decforene. Yes. So basically there should be 10 carbon atoms. And Is there any answer? 28B. Oh, we already went through it. Okay. The next one, the correct structure of 2,6-dimethyl dec-4-ene. What's that? Decane 4-ene. So there should be a double bond at the 4th position. So there are different structures given. Let's give the minimum number to the functional group, which is a double bond. So everywhere I'm starting from the end where the double bond is going to get the minimum position. 4, 5, 6, 7, 8, 9, 10. Here this should get the lowest number. So I'm going this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can follow the shortcut too, but I'm just explaining the proper method first, then we'll see what you can do. 9, 10. And here also I'm going to number. I'm going to number from down because the functional group should get the minimum number. 4, 5, 6, 7, 8, 9, 10. So now see, when you name 4, the double bond is at the 4th position in which of the compound? It's at only option C. So that should be the right answer. Let's check the rest. So once you name the compound, once you number the compound, what you're going to do is where exactly you find the 4-ene. That's only here. Option A is not the right answer. Option C is the right answer. That's right. So at the 4th position, you have ene, and 2nd position, you have methyl group, and also the 6th position, you have a methyl group. So this should be 2,6 dimethyl dec-4-ene. That's the right answer. The correct order regarding the electronegativity of hybrid orbitals of carbon S. So whenever you say the electronegativity, we know that when you say s orbitals, p orbitals, d orbitals, f orbitals, s orbitals are closer to nucleus. They have more attraction over the electrons. The electrons which are present in the s orbital experience more attraction. So more is a percentage s character in any orbital, more will be its electronegativity. I'm just writing En. Hope you understand that. If I say that you calculate the percentage, the option is C. Someone said C. Let's see whether it is C. So it's SP, SP2 and SP3 we have. Totally, we are going to take them as 100%. If this is 100%, S will be 50% and P will be 50%. Here P2. So totally, if you take 3 orbitals, divide 100 by 3, that is going to give you 33.3. So S is only 1 time. So this is 33.3. And the P orbital is 33.3 times 2. That's 66.66. And totally, there are 4 orbitals. 1 S and the 3 P orbitals. So there are 4 orbitals. And what you are going to be, ma'am, I'll check. So S is totally 25 and P is 75. Okay, now you see where the S character is high. So SP has higher S character, so this is more electronegative. Then comes SP2, then comes SP3. So let's check it. SP has higher electronegativity. Then comes SP2, then comes SP3. So option B is right. You are right. So this is about some of the compounds and their nomenclature and their hybridization, etc. And in this particular chapter, you can always expect one question in the topics which we covered today, in the questions which we covered today. The similar type of questions will come for sure for NEET. And if you like the video, please press the like button, and then don't forget to subscribe. Thank you.